In this video, we are going to prove Kepler's third law. Proof of Kepler's third law. What was Kepler's third law? Kepler's third law says that the time period of revolution of a planet around Sun is proportional to cube of square of time period of revolution of planet around Sun is proportional to cube of length of same major axis. So length of semi major axis. See, planets are moving in a elliptical orbit. Let me draw the figure. This is elliptical orbit. So planets are moving in this elliptical orbit, and these are your axes. This is your semi major axis A, right? And over here you have a focus. Suppose Sun is at this focus and planets are moving like this. Sun is lying at this focus and planets are moving, the planet is moving around this, right? So R is measured from this focus. This is theta, this is R, and we have already derived the equation of motion of planet around Sun in terms of plane polar coordinate with focus as one of the origin. So what was the equation? The equation was L square upon GM M square 1 by R 1 plus E cos theta, right? 1 plus E cos theta. So R can be written as L square upon one plus E cos theta, right? So what is the time period of revolution? See, we have already got the aerial velocity. The aerial velocity is given by L upon 2m. This is aerial velocity. Aerial. So suppose the time period of revolution, the time period of is t. So in t time period, this radius vector is going to sweep the whole this ellipse. In t time period, this radius vector r vector is going to sweep whole ellipse. So this is going to be area of ellipse. And what is the area of ellipse? Area of ellipse is pi ab. Pi ab. So we are getting an idea that L upon 2m into 2, this is pi ab, and we have one more relation. B is a 1 minus e square. So this is going to be we can write it like T is pi a square 1 minus e square into 2m by L. So how will you get L now? See, we have one condition. See, this is theta equal to 0. At theta equal to 0, what is the value of this R? Value of this R will be a minus ae. See, this is a1 minus e at theta equals to 0. So this is equal to, at theta equal to 0, this will be 1 plus e. So from here we are getting L square as GMM square 1 minus e square, and that gives us L equals to GMM square under root, right? So let's put it over here. Pi a square, am I correct? One thing is left, I think I have left a, so it will be a. So pi a square 1 minus e square upon 2m, and L is what? GMM square a 1 minus e square. So this will cancel out. This will cancel out, and what will remain? This will cancel out. So this will be pi upon, or 2 pi upon gm a to the power 3 by 2, right? So t is proportional to a to the power 3 by 2, that means t square is proportional to a cube. t square is proportional to a cube, where a is length of same major axis, where a is the length of same major axis. See, if it is circular orbit, this derivation is very straightforward. If it is circular orbit, if the planet is moving or satellite is moving in a circular orbit, this derivation is very obvious. That is very easy, in fact. That comes directly from Newton's second law. Suppose the planet is moving, say it is Sun, and your Earth moving in a circular orbit, though it is not moving in a circular orbit, but if I assume that planet moves in a circular orbit around a star, in that case, if it is moving in a circular orbit, say of radius say r, then in a way it is undergoing a kind of, or let's say this is small r, then in that case it is undergoing an acceleration radially inward direction. And what is the acceleration? Acceleration v square by r. That's called centripetal acceleration. That's called centripetal acceleration. And what is the force in radially inward direction? The force is gmm by r square equals to mass into acceleration. That's a Newton's second law. This is the net force acting in radially inward direction. It's a mass into acceleration radially inward direction. And in a circular orbit, v is equal to omega r. So we can write it as v omega square r square upon r, which is m omega square r. Is it not? And this omega is what? Omega is angular velocity, which can be written as 2 pi upon time period. Which can be written as 2 pi upon time period whole square. So this gives us 4 pi square m upon t square r, or this m and m will cancel out. So this gives you t square equals to r cube gm, yes, 4 pi 4 pi square. So in a way you see t square is proportional to r cube, because in case of circle r is the same major axis. In case of circle, radius of circular orbit is the same major axis. Right? So this way we can prove Kepler's third law. This way we have proved here in general for any elliptical orbit, and for circular orbit it directly comes from Newton's second law. It directly comes from the application of Newton's second law. Newton's second law gives you Kepler's third law over here for circular orbit. In case of elliptical orbit, we can prove it this way. We can make use of area velocity, and from there we can get the idea of time period, and then we can prove that time period is time of revolution. Time period of revolution is directly proportional to cube of your same major axis. This is constant. This is constant, right? This is constant. So in this way you can do this proof. All right. Thank you very much.